I find it quite entertaining just how often people say how they hold all their coins on a wallet, um, and they don't realize that they actually don't. So what I quite often get in crypto groups is when people say to me, what do you mean the wallet doesn't actually contain any coins? So I'm going to describe and explain how they actually work and what they do. What I was going to quickly cover was some concepts like cryptographic hashes, public and private keys, and what a wallet actually does and how it all appears on a blockchain. So to begin with, we've got, first bit of buzzword, we've got a thing called a cryptographic hash, which is a calculation where you take any input, you apply a mathematical function to it, and it produces a unique output in some way. So it's like a digital signature. And one of the hashing algorithms, one of the mathematical functions we use in Bitcoin is one called SHA-256, which is secure hashing algorithm 256. And there are many other algorithms that can use as well. If we look at what this does, it means if we take the word Gary, we just type it into a Word document or we type it into a calculation or whatever. If we apply a cryptographic hash on it, the output on it just looks like jumbled load of code. You can see there it's like 55F21, blah, 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 blah. So the thing about a cryptographic hash is that it encodes something in a way that the encoded output can't be used to work out the input. So it's one directional kind of thing. And if you make a change to anything whatsoever on the input, so if we change Gary to capital Gary, or add a 0 at the end of Gary, or at the beginning of Gary, you'll see that the output from SHA-256 comes out with a completely different output every single time. And you'll notice I've given an example of at the bottom using SHA-224, which is a different encryption algorithm. The output from that is different again. So the great thing about these cryptographic hashes is that you can't use the output to work out the input. You can't compare the output of the hashes to see what's changed. All you can tell is that something has changed. And they offer something which is called deterministic. And that means if someone takes a SHA-256 algorithm and puts exactly the same values into it as somebody else does, then you'll always get the same output. So that means if I run SHA-256 algorithm on Gary, I'll get 55F blah, blah, blah. If either of the Chris's run the same algorithm on Gary, they will also get 55F blah, blah, blah. So very, very useful thing, cryptographic hashes, and we'll see how they're used in a minute. So what we now have is in Bitcoin, we have a thing called a private key and a public key. A private key is just a completely random number. It's any number out of, it's 2 to the 256 or something. It's more than potential atoms of the universe type of thing, just a purely random number. But we run a thing called ECDSA, which is elliptic curve digital signature algorithm, which is another hashing type algorithm, which pairs up a private key to a public key. A private key shows you own the public key because they are linked. But you can't actually use a public key to figure out what private key is. So the two parts of a jigsaw, and a private key proves you own a public key, but you can't use a public key to identify what private key is. And what we also do is you've got this private key and public key thing, so they're just like random numbers and that, is that you then hash them, or you hash the public key rather, to give what's called a Bitcoin address. And actually it goes through a series of hashing. So you take the public key and you do a SHA-256 encryption on it, then you do what's called RIP-END 160, then you do base 58, and that gives you a Bitcoin address. The reason it goes through multiple different hashing algorithms is it's a security feature that if SHA-256 is ever compromised as an algorithm, you've still got RIP-END 160 as an additional layer. And then base 56 just convert it into something that's a little bit more readable. The really critical thing about all of this at the moment is never share your private key with anybody. If you want people to send money to you, or send crypto to you rather, you can share your Bitcoin address, but never share your private key. because if they have that, they can access your wallet. So the next thing, what a wallet actually does is quite often you'll use what's called a seed phrase, which is the wallet software uses to generate a private key and public key, and from that, a Bitcoin address. So the really powerful thing about this is that you've now got your wallet, which might be hardware or software, which you use to effectively manage all of your keys and of your addresses. If the worst comes to the worst and you lose your wallet, so say you've got a nano ledger or a Trezor or something like that, if you lose it or it doesn't work or anything, or it breaks, you can actually go and get another new wallet, use the seed phrase to generate the private key, and then you can use that wallet still. So the key thing from this is that not only don't ever share your private key, but don't ever share your seed phrase, because that can be used to create a new private key, and don't lose your seed phrase as well. That's really, really important. So the next thing that a wallet does is that it takes any transaction. So say you want to sell some Bitcoin to somebody else, it takes your Bitcoin address, it applies again through cryptography, a signature to that using your private key, and it generates what's called a signed transaction, which has got your Bitcoin address in it and a signature to prove that you are the owner of that private key. And all that data then gets written to the Bitcoin blockchain. So the wallet signs the transaction using a private key, and that means that using the combination of the transaction, signature, and public key, it's all verified as a legitimate transaction, and it's that transaction that's written to the Bitcoin blockchain. And this is the thing that the wallet software can either do that directly to the blockchain, or it can go through an interface in some way. The other thing is that a wallet does is it reads in the values that are on a blockchain ledger, so Bitcoin, for example, to make sure that funds are available against a particular Bitcoin address. It stores your keys, it signs your transactions, and then it writes records back to a ledger. So the wallet signs the transactions using a private key, and it stores the key, and it links to a ledger. And that's all a wallet actually does. It actually stores your keys, signs transactions, and connects either directly or via software to the blockchain. Okay. And then finally, once that's all done, you have to remember a wallet doesn't contain any coins. And so I think of it as, it's like a real wallet with debit cards in it. And what that means is that the debit cards give you access to your account, but they're not your actual bank account. And finally, the outcome of that is when we go on to the actual Bitcoin blockchain, we can see here a transaction I've highlighted in yellow, where it's going from this blockchain address of BC1Q, whatever it is, and it's writing out a whole load of transactions to other wallet addresses, including its own. And that's the thing about Bitcoin. Bitcoin uses a principle known as unspent transactions, or UTXO. So if you think about, if you hand in a £5 note at Starbucks and your coffee is £2.99, then you get your coffee and you get your change back. Well, it's the same with Bitcoin, that you always have to hand over all of your Bitcoin in that wallet address, and if there's any left over, you send it back to your address. So that's the thing you might hear about unspent transactions. This is all a wallet effectively does, whether it's a hardware wallet or a software wallet, in that it checks against the ledger to make sure that a wallet address has got sufficient coins to spend, and then it writes a transaction, which is a signed transaction. You don't even see the signing information in here. It just accepts it as valid, and it writes it out to the blockchain. So that's it, really.